Hello, everybody. Good afternoon. We are going to start with the next talk, which is about Audit and Namespaces by Paul Moore. So please help me welcome Paul.
Hi, everybody. Can you hear me okay in the back? Yes? Good? All right, great. So my name is Paul Moore, and I have to say this presentation that I'm giving to you today wasn't actually created by me. It was created by somebody else on the audit team, Richard Briggs. He works for Red Hat. Some of you may know him. Unfortunately, he couldn't be here this weekend for DevConf, so they asked me to kind of step in and do the presentation. But it's a good presentation. And Richard actually gave it at the Linux Security Summit this past summer up in Canada. And it was great. We actually recorded the videos for the first time this year. So if you want to see Richard actually give the presentation and do all the Q&A, you can go to that YouTube video. So come on, everybody, get your cell phones out. Take a picture of the URL. Really? I only see one person? All right. Anyway, you can also, if you just go on YouTube and search, Audit Namespaces, Linux Security Summit, you'll find it. It's a very well done video. Actually has some production value in there. So anyway, I would encourage you to check it out. It's 45 minutes in length, I think, so it's not too long. And it's much more interesting probably than what I'm going to be able to give you today. So anyway, this slide I actually added. I kind of thought about giving Richard's introduction slide to see if anybody would know the difference between me and Richard, but I figured that would probably be kind of a joke lost on many of you. But anyway, so if you watch the video, this slide is different. Anyway, this is me. That's my Twitter handle. I don't use Twitter an awful lot, but if you do send me a message or whatnot, I will respond to you. Those are my email addresses. I tend to use both. I use the paulmoore.com one a lot for the upstream things, but you also see me use my Red Hat one quite a bit too. They're the same person. For the past several years, I've been using Linux since maybe the mid-1990s. I've been actively engaged as a Linux developer since maybe 2004, I think. And I'm currently acting as the SE Linux audit and labeled networking maintainer for the kernel. I also created the libsecconf project. Happy to talk about any of those if you want during the conference, but today we're going to be talking about audit and namespaces. And actually, a quick show of hands. How many people are here for containers? Okay. Now, how many people are here for audit? Wow. All right. I was thinking in my head last night when I was going over the slides, it would have been completely the opposite. I was expecting everybody to raise their hand for containers and like 2 of you to raise your hand for audit. And that's primarily because there's my boss and my boss's boss here, and I figured they'd be excited about audit. So anyway, all right. So good news, we're talking mostly about audit, not so much about containers and namespaces. Because quite frankly, it's an interesting story. So anyway, let's get right into it. So first of all, what is audit? Hopefully this is not a new concept to you guys, and based on how many of you raised your hands, I think you know the basics of audit. But for those that don't, audit was created back in 2004 by Rick Faith, who worked for Red Hat at the time. I'm not even sure if he still does. I don't know. But it was a Red Hat project. Auditing on Linux actually started before this. SUSE had an implementation, which for whatever reason wasn't able to be merged upstream. But audit as we know it today started in 2004. Dinosaurs weren't roaming the earth then, but we at least remembered when they did at that point in time. A lot of people like to talk about audit as syslog on steroids. I don't necessarily like to think of it that way, but if you do, that's okay. It's not completely wrong. The whole point of audit is to have a more secure logging mechanism in the kernel. The reason is, about the time that audit came into existence, we were starting to take Linux through a lot of third-party security evaluations. Things like common criteria, which is a very rigorous security evaluation. And I see some common criteria people in the back that smiled when I said that. So it's a very difficult, very painful process at times because you really have to go into the whole operating system in very fine detail, explaining how everything works and making sure that it works the way that you said it does. So it's a very interesting thing. And one of the things we realized when we were doing that is we didn't actually have a good security guarantee around a lot of our logging that happened. We've got syslog, and syslog is great, but syslog ends up in var log with a lot of other application log files, and it turns out for practical reasons, it's very hard to secure that log. At least secure it to the sense that there was enough integrity around the log that lawyers could feel good standing in a court of law and saying that, based on these log file entries, Bob did this and Sue did that at this point in time on this system. So we needed a better mechanism, and that's why we created Audit. It works well with SE Linux, and it works well with SE Linux for two reasons. One, it's a great tool for SE Linux to report on things. When there's an SE Linux denial, I'm sure we've all seen an AVC message, right? Wow, okay, I also do SE Linux, so I'm really happy when there's not very many hands that go up for that. But anyway, so it's a great reporting mechanism for SE Linux. It's also very good because of the way it's structured. All of our audit logs go in its own directory, so it makes it very easy for us to tighten down and harden that directory. Because the only thing that goes in is audit logs, so we can lock that directory down using SE Linux for other applications, which helps guarantee that integrity that we're looking for. Audit's a bunch of different pieces. There's obviously the kernel component, which I've been talking about, but there's a very important user space component to this as well. There's obviously configuration tools, and there's a lot of neat little tools for parsing the logs and doing cool reporting. In fact, I'm going to do a shameless plug. Is Steve here? He'd be very disappointed because I'm actually going to plug his lightning talk. If you go to Steve's lightning talk, if you look on the board, you'll see there's a big audit announcement. It's kind of cool. I won't steal his thunder since he's not here. But if you have a chance today, go check out Steve's lightning talk. I think you'll like it. So anyway, so there's that part of it. But for the things that we're going to be talking about today, one of the more important things for auditing is the audit daemon. This is the component that sits on your system that takes all of the log information from the kernel and either writes it to a disk, sends it out to the network. It's a pluggable mechanism. So if you have your own special log aggregator or whatnot, you can hook directly into the audit daemon and get those log records out of it. We also have the normal, configurable kernel filters. I mean, you can obviously do filtering after the fact on the logs, but most people who use Audit heavily generate gigabytes of log information on a daily basis. And you can imagine as your enterprise grows, the logs only grow. So one of the ways we can kind of combat that is with these kernel filters so that you can specify only what events you're interested in. If you wanted, you could log every single syscall invocation on the system. It's a great way to crash your system. But you could do that. So anyway, and finally, the last point on the slide, this always seems a little silly to me, but some people do think Audit does something differently. Audit doesn't actually enforce any security policy. With one exception, I'll tell you in a minute. Mostly it just reports on what's happening on the system and any violations from the other security policies on the system. The one exception to that, and I doubt anyone here in this room has this enabled. It's definitely not the default. But you can set it up so that if something happens to your system or the audit logging mechanism such that it can no longer safely record audit records to disk, you can panic the system. The idea being that there are certain groups of users and certain groups of system administrators that if they can't have a log of what is happening on the system, they don't want anybody to use it. It's kind of like, if I can't play with my toys, nobody can play with my toys, sort of thing. So anyway, that's the only bit of security policy that Audit actually enforces. Everything else you see in the audit log, that's somebody else's fault, not ours. So don't blame us. All right, so anyway, I'm going to talk about namespaces, but before I do, now that I got the quick audit introduction done, I like taking questions while we go through the slides. I think it's a lot easier than asking you to remember all your questions until the end after I've thrown all this stuff at you. So feel free when I get to the end of the slide, or if I'm in the middle of the slide, raise your hand and I'll try and answer your question. And also remind me to repeat your question because we're being recorded. I'm really bad at remembering that. So anyway, namespaces. In short, Richard's first bullet here is kernel-enforced user space views. And that's a great way of looking at it. One of the ways I always kind of thought of it is that we're all familiar with virtualization, right? There's Zen, and there's KVM, and QEMU, and whatnot. And that was hardware-based virtualization. And it gave us different views of the hardware. Namespace is the same concept, except instead of giving you different views of the hardware, we're giving you different views of the system. Okay, so we've got, let's see, what do we have? We have 7 different namespaces here. If we look at the first one, the mount namespace, which is kind of interesting in its own right, basically that just gives you a different view of the file system. Okay, so every application on the system, if it was running in its own mount namespace, could have a different view of the file system. You could have different home, you could have a different user, different var, different temp. It's kind of a neat thing, especially when we start talking about some of the other namespaces that are on here. But the first point, Richard's kind of got these segregated, you'll notice, into peers and hierarchies. And this is an important distinction. If we see the top 4, those are all peers. And what that means basically is a very flat structure. We were talking about the mount namespace, for example. So what that basically means is if we've got 4 different applications, each running with their own mount file system, they don't necessarily inherit anything from each other, okay? They all see a different view and they all have a different representation. They don't inherit anything, okay? There is no hierarchy, all right? That's why we call it kind of a peer. And we've got that with the mount namespace. We've got that with the UTS namespace, which if it didn't say host name up there, would any of you know what the UTS namespace was? Yeah, okay. I'll be honest, when I first heard of the UTS namespace, I was kind of, what is UTS? That's the host name, domain name information, and whatnot. The IPC namespace, this is all the IPC mechanisms, shared memory, all the sys5 stuff, the Unix domain sockets, I believe. When Richard was first putting this presentation together over the summer for the Linux Security Summit, we were going back and forth, and he was kind of using me as a dummy to do the presentation. And he presented that, and I asked him, I said, yeah, I know about the IPC namespace, but I can't think of anybody that actually uses this. Can you? And he kind of laughed, and he said, I went and looked at it too when I was putting the slide up. I can't think of anybody that uses the IPC namespace. So it's there, and you can see it's been there since 2619. It just doesn't appear to be very common. We're not sure of anyone that is actually using it. Then there's the network namespace. That's also a peer namespace. It's very cool. This, I think it's easy to think of how you might use that, especially the way it's implemented. Every namespace gets a fully independent network stack, which is kind of nice and handy. The way it starts off, you create a network namespace, and all of your network interfaces live in the initial namespace, and then you have to go ahead and move them into the individual network namespaces. The only way you can talk between network namespaces is to actually talk out over the network and come back in. Now we have some neat little things. We have some virtual Ethernet device pairs so that you can set it up to talk between the 2 interfaces. But all your normal things, like you can set up a firewall between applications on the same system, which is kind of interesting if you think about it. IPsec stacks, all that stuff. It's kind of a nifty little thing. But anyway, let's see, and that came in 2624. All those have been around for quite some time. Next, we have the hierarchical namespaces. Probably the easiest one to think of, at least for me anyways, the PID namespace. We all know on the system, for better or worse, everyone became very aware of process trees when systemd came about. A init runs is PID1, and then it goes on from there. Well, the idea with a PID namespace is you can create your own namespace, And the first process in that PID namespace becomes PID1. And then it goes on from there. It's hierarchical in the sense that you create a PID namespace, and let's say you're running bash. It's the first process you start up in that namespace. So that gets PID1. But it's hierarchical. If you're in the initial namespace, so if you're in the host system before you started that namespace, you'll still see bash, but you'll see it with a different PID, which is a bit odd if you think about it. So this one process can have a different PID depending on which namespace you're in. If you're in the initial namespace, might be PID 3000. But if you're in that bash instance, which has its own PID namespace, if you ask it, hey, echo $, was it $, I think? I can't remember. Anyway, it'll show up as PID1. So it's kind of interesting, and it has some very interesting ramifications for audit. Because if you think about how are we going to start logging actions for that bash instance, if it does something security relevant, we want to tell the user, okay, it was running with this PID. Which PID do we use? Do we use the PID from the namespace, its own namespace, or do we use the one from the global namespace? So that presented some interesting challenges we'll talk about a little later. Then there's a user namespace, which, depending on your point of view, this is either the greatest thing to come along for Unix security in years, or it's a source of tremendous terror and fear. I tend to fall in the later camp of terror and fear. Some people have those dreams where you wake up and you're falling. I have these terrible dreams where I wake up and I'm in a horribly mismanaged user namespace. Judging by the amount of laughs, I'm assuming that you have those dreams too, maybe? Anyway, so that's that. We'll talk a bit more about that later. And then we have C groups, and this, I believe, was the last namespace that's come along. I'm not aware of any that are in development. Maybe you do. So the basic idea around C groups, right, is to put resource constraints on processes and groups and whatnot. The C groups namespace allows you to have a hierarchical representation of that. So basically, you can sort of hide these limits from the things that you're running in a container, which can be very handy. All right, so I talked an awful lot on this slide. Does anybody have any questions before we move on? All know everything there is to know about namespaces. All right. So what are containers? So there's probably a lot of you that aren't going to like what I have to say here, but from a kernel point of view, containers don't exist. They're a fiction. Yes?
We just searched, there's 15,000 references in the latest kernel to containers.
Right. They don't exist. It's kind of, I like to think of containers much like Santa Claus, right? People get all excited thinking about Santa Claus. People get all excited thinking about containers. But if you go around and you talk to people, really talk to people about Santa Claus, you get different answers from each person, right? You go talk to a kid in America, he'll tell you one thing about Santa Claus. You come talk to a kid in the Czech Republic, he'll tell you something totally different. You go talk to a kid in Brazil, he'll tell you something totally different about Santa Claus. That's kind of containers, really. That's how I think of it anyway. The kernel has no concept of containers, and as such, it's up to user space to define what a container is. And as we all know, there's plenty of container engines out there, right? I mean, Docker's the big one that everybody always talks about, but they're definitely not the only one doing containers. And depending on who you talk to, you're going to get a different answer as to what a container actually is. However, the thing that seems to be common across the containers, and even different configurations using the same engine, is that it's some mix of namespaces, some form of sandboxing. SecComp is kind of the popular one, but SE Linux you can also think of as sandboxing. Wave, Dan. And C groups, right? Because, especially for people that provide these as services to people, you definitely want to make sure you restrain them so that one container doesn't go crazy and steal all your CPU or network. And so anyway, and Richard's probably, if you listen to his talk, he's a little more polite about this. He put the kernel has no concept of containers halfway down the slide. He kind of buried it. A little more direct, I guess. So anyway, the kernel has no concept of containers, which is interesting as we get a little farther into this presentation talking about the audit impact. It's really up to the user space container manager to define what the container is and report on it and track on it. Because the audit subsystem in the kernel, really, we have no clue. People have all these requirements for around container logging, and at this point in time, it's like what's a container, So it's definitely a challenge. And one of the ways we're looking at solving it, this last point on the slide, is creating some form of container ID or a set of namespace IDs, okay, to somehow uniquely identify actions that happen inside the kernel as being associated with a container. And this is still an ongoing discussion, you'll see as we get going. All right, so what's the problem? And when we talk about audit and namespaces and containers, there's really kind of two issues that we worry about, or two issues that we run into all the time. One is, as I talked about earlier, we have the audit daemon, okay, and that's responsible for basically doing all the audit stuff that people really care about. That actually generates the audit logs. And so, where does that run? Is that running in a container? Does that have to run on the host system? Then there's also the issue of all of the various trusted applications that run on your system. For example, when you log into your system, PAM generates an audit record saying, hey, you've logged in. VSFTP, if you were to log into VSFTP, it generates some audit records. I'm mentioning both those because we'll see later in the talk that those actually caused us a good deal of problem. But basically, it's first slide, Highlander, there can be only one. Right now, there can really be only one audit daemon on the system. We can talk about this more, but in practice, that doesn't actually seem to be too bad of a restriction because it's fairly rare on most container workloads that you actually want to run auditing inside the container. Most applications that run inside the container have some very good logging of their own. It's usually only when you start talking about, trying to manage your whole system, that's usually when audit gets involved. And so just having that run on the host, basically on the initial namespace, is usually sufficient for most workloads. The mount, the UTS, that's the host name, the domain name namespace, and the IPC namespaces, we have no problem. We've never encountered any issues with that with audit. Things are pretty much wide open. Everything was working well until about 3.7 RC1 timeframe. Then we kind of started noticing problems. Some of these were problems that existed for a while. It just happened to be that the way user space was evolving, the way the kernel was evolving, they didn't actually become real issues. First one was the network namespace. The issue was that all the communication between the audit daemon and the kernel and between the trusted applications in the kernel, things like PAM and VSFTP, happen over a netlink socket. Okay? Netlink, for those of you that don't know, effectively relies on the networking infrastructure to deliver messages between the kernel and user space. Well, if you had a separate network namespace, and you were trying to log in via PAM, the issue that you'd run into is it didn't necessarily work. We'll get into more of that. I'm getting ahead of myself. But that caused this problem. We fixed that in 3.14, which was a long time ago, so you guys should be good now. We had another problem with PID namespaces. We'll talk about that in a little bit. The user namespace, as I told about, you either think it's great or it scares you. There are some possible security concerns. We're mitigating those right now, explain how, but eventually we're going to have to address those. And audit D. Basically right now, you have to run audit D in the user initial namespace and the PID initial namespace. Everything else, you can run it however you want, but it's got to be in the initial namespace for PID and for user. All right. So network namespace. This was started to explain on the past one. So you've created a new network namespace, and you're trying to log in. Let's say, I don't know, using SSH, or you're just trying to log in on the console. It breaks. And you want to know a great way to upset developers, users, Linus, basically prevent them from logging into their system. It's a real great way to get a lot of angry hate mail real quick. So anyway, when you break something for such a wide group of people, you get a lot of proposals about how to fix it. Because this was pretty wide-ranging, the least complex, so the simplest and quickest fix won out. And it turns out it's not a bad fix. Basically, the problem was that when PAM started up, it tries to open a netlink socket up to talk to the kernel to say, hey, Bob logged into the system. On a system where you don't have audit configured and it's not running, you would get econ refused. And so PAM is coded up in such a way, so if it tries to open up this connection, if it gets econ refused, it says, okay, you don't have audit configured, that's fine, ignore audit, I'm just going to keep going and log in. Well, when we quote, quote, fixed things for the network namespace, basically that all of a sudden allowed that connection to be visible. And the problem was there were certain cases where instead of now getting that econ refused, you would get eperm. And well, the way PAM was configured, because this code was written long before anyone was thinking about namespaces, people looked at it and said, oh, hey, okay, whenever we get eperm back, that means that audit's configured, but something has happened that's denying us to generate an audit record. And so therefore, this person is doing something bad, we don't want to let them log in. So in the process of fixing our problem for network namespaces, we pretty much just locked everyone out. So much as you do in real life when you find yourself in awkward situations, sometimes you tell a little lie, right? It's not good. And so that's basically what we do here. We sort of lie a little bit, and in these particular cases, when you're not in the initial PID or user namespace, we basically lie and we say econ refuse so that PAM still operates correctly and life goes on. So also in real life, when you do give these little lies, it comes back to haunt you later. We know this is going to be a problem later that we're going to have to solve. It continues to haunt us. But the facts are we have to solve a lot of other problems first before we can get back to solving this one. PID namespace. So last slide I talked about problems where we broke PAM. Now I'm going to talk about the slide where we broke VSFTP. Basically, VSFTP auth is a way of sandboxing, created its own PID namespace before it would do the user authentication. And for a variety of reasons, and as I'm looking at my watch, I'm going longer than I anticipated, so I'm going to start talking, I'm going to gloss over some details. That was not working. So basically, it was capabilities and all this good stuff. We fixed that, and perhaps more importantly, what I wanted to talk about and alluded to earlier was the whole PID namespace and the fact that you can have one process with multiple PIDs if you're in a separate PID namespace. And so process of doing this, we realized that we weren't necessarily, in the kernel, always recording the right PID. What we want to do is we want to record all the PID information relative to the initial namespace. Because the majority of the time, when the administrators come on, they set security policy, and they have all the logs generated, it's logged with the information from the initial namespace. Because otherwise, we would see a normal user going off and doing a bunch of things as PID1, and that's kind of misleading. And you would have a security administrator looking at this going like, wait a minute, why is Apache running as PID1? How does that happen? So we had to clean up a lot of the code in the kernel to make sure that we were always translating PIDs and logging things correctly. User namespace. This is, as we talked about, this is one area where things are still ongoing. There was a lot of patches posted in 2013. There was some good discussion. You can Google the Linux audit, Linux-audit, to get to the mailing list, and we have archives. And you can go back and you can check it out if you're interested. Once again, we don't have time to go into all the details, but there's a lot of good discussion. There was even some talk about creating a audit-specific namespace. Ultimately, everyone decided that that was probably not a good idea for the simple reason that you don't want to have audit records off in their own namespace because you want to be able to have visibility to everything from the host system. You don't want someone to be able to hide in a namespace. At least that was what convinced me. But anyway, so we're working on that. Right now, as I said, you have to run audit D in the initial user namespace. There's kind of no way around it. Eventually, though, we want to work towards a system where we can have multiple instances of audit D, one for each user namespace, or at least allow you to have one for each user namespace. We wouldn't force you to do that. And that presents a lot of interesting things, especially when we start talking about in the kernel, because everything in the kernel right now is architected around one audit daemon. And so if we start having multiple audit daemons, we need to look at it, and we have a queue of audit records that the kernel builds up and that we push up to user space, as you do with any sort of communication channel. But if we were to start namespace, if we were to start allowing multiple instances of audit D, we need to start looking at, okay, we can't have a single queue anymore. We're going to need to split that up, because otherwise you could run into a situation where one container could overflow the queue and start choking out others. There's also, we talked in the beginning about kernel filtering for some of the audit records. Well, we would need to have, in addition to your own queue, we would need to have your own rule set, because what an audit D in one container cares about is obviously going to be different from what another container cares about. And the host audit D is probably going to have a completely different set that's independent of everything, because they're probably going to want to watch individual containers as well as the own system. So it's actually quite a tricky thing. And we also want to make sure that if you try to configure the kernel in one of the namespaces, that you're not making a configuration that's going to adversely affect other audit configurations that are set up in other user namespaces, as well as the host system. So for example, I told you about the panic. We don't want somebody in a user namespace to be able to configure the entire host system to panic if something goes wrong with audit. Because otherwise, I mean, imagine that. You could have a container. Somebody sets the system up to panic when something goes wrong with audit, and then that person just floods the system with audit records and wedges it, and then the whole system goes down for everybody. It's a great way to get your container provider upset with you. So anyway, and those are just the problems we know about now. As everyone who's done software development will tell you, there's the problems when you start, and then we get halfway through, there's another set of problems that you had no idea even existed, as referenced by the fact we locked everyone out of PAN via FTP. So I'm sure we'll uncover more as we start going down the prototype path, but that's at least what we're aware of at the moment. And so the namespace ID. Way in the beginning of the presentation, 40 minutes ago, talked about how one of the ways we need to reconcile the fact that there's no such thing as a container is we need to somehow come up with something, a namespace, a set of namespace IDs or a container ID, something that we can assign to each audit record so that system administrators, when they look back in the logs, can say, okay, this event happened in this container and this event happened in this container. And there's been multiple attempts over the years. I think the first one started back in 2013, where we were using some proc inodes to do that. And the namespace folks were a little upset with that idea. The checkpoint restore people were very upset with that idea, because what happens if you were to freeze a namespace, freeze a container, move it to a different host and restore it? Yeah, the inodes aren't going to match up. And that pretty much, that reason right there is what knocked out the first three things on the list. Richard came up with an idea of a serial number, a monotonically increasing number, starts at 1, and each time you created a new namespace, it would increase. But the same sort of problem. Once you started moving things across hosts, well, what if somebody has the same number? How do you resolve that? You can't easily change that number without the user space running inside of that container having some issues. And then there was some talk about, similar to what they were doing with the proc inode, they wanted to do it with the namespace file system, but they included a dev number with the inode. So that helped a little bit, but you still have the problem when you start crossing hosts in a whole enterprise. So that was kind of difficult. One of the things, let's skip ahead just a minute. Yeah, okay. So that's pretty much it. The namespace ID, we haven't completely ruled it out, but I think we're definitely trending towards, and I want to say my mind is almost convinced, that we're going to have to start going over to a container ID. Container ID is basically, it's going to be a token, a number, or something that the kernel is going to have absolutely no clue what this is. Your container engine will set it. Your container will basically tell the kernel, it's like, all right, this process has this container ID, and we want all the children processes from that to go ahead and inherit that container ID. Unless, of course, you start up another container engine inside there, and you pivot it off, that's fine. And we have some precedents for doing this in the kernel today with session IDs. For those of you who may not be familiar with Audit, session ID, when you log into your system, it gives you a new session ID. And everything you do from that point on the system, you could sudo, you could su, you could change SE Linux roles, you could do all sorts of things. But that session ID remains the same. So it's an easy way for your system administrator to track everything you do on the system. I didn't mean to make you paranoid. That sounds really bad now that I say that. Dan. You like how the way I said token? Oh, sorry. Remember I said I was really bad at repeating the question? So Dan asked, and stop me if I'm wrong, but you were asking basically, does the ID have to be an integer? Could it be a UUID or something like that? Some arbitrary value, right? Okay. So no, I mean, we haven't created this. We haven't coded it up. Now, the one concern I would have with UUID, every UUID I've ever seen is really long. And a lot of the audit people want really short things because they have gigabytes of data per day. And they don't like spending a lot of bytes for things like that, especially for something that's going to be in every audit record.
No, I don't mind if you have. I'm looking for something that we could use for other purposes.
Okay, so Dan was saying that he doesn't care about particular UUID. He just wants to usurp this and use it for other devious things. Because that's what Dan does, devious things. He's laughing. But anyway, this is all possible. I mean, just a second. So it's all up for discussion. We haven't actually designed this or coded it up yet. It can't be huge. We're not going to let you abuse this too badly. I mean, people are going to abuse this, but we're going to try and limit the abuse. But the point is, this will be a token, this will be a value that the container engine is responsible for setting, and the container engine is responsible for managing, basically. We'll just carry it along in the kernel and do the right thing that way, but the user space will have to tell us. So, I'm sorry, what's your question?
The question is, when will this thing be ready? So what? Because I need that for my work too. Now, because I want them to provide me something for my infrastructure that gives me a container ID that I can request via a Unix socket. So how long will this take?
Right.
How can it speed it up?
How?
Help you to get it faster?
Okay, so the question is basically, I want this 2 months ago. When can you get this done, you stupid man? Not letting me do anything I want to do. I mean, I wish I could give it to you today. I wish we had it done. There's only so many of us, right? If we get a lot of people, yeah, I know. The person sitting next to him happens to be my boss's boss who really wants this too. So all I can tell you is that there's a lot of people that want this solved. You're not the only one. It's a... How? I'm sorry, say what?
He asked how he can help.
Hey, it's all open. Oh, sorry. The question is, how can he help? And all right, we're kind of running out of time. I'm going to skip the conclusion for right now because I think we sort of talked about this. There you go. Camera phone, take a picture of it, get the links. There's the mailing list. We're on GitHub. We actually have a GitHub tracker tracking this. It's issue number 32. We have a mailing list. The mailing list I'm posting up here is the Linux audit mailing list. I'd imagine eventually as we get further down the line, we're also going to talk to the container folks on their mailing lists. But since we haven't quite sorted everything out from an audit perspective yet, we would just kind of ask, limit it to the audit mailing list because we don't want to get sucked into a bunch of different rat holes. So we want to make sure we know all the requirements from an audit point of view first before we start talking to the container people saying, hey, here's what we're thinking of doing. What do you guys think about this? And part of this is also we're in the process of collecting requirements too. I mentioned in the beginning this little thing, common criteria, which is very important to Red Hat. And we need to make sure that we are doing the right thing from a common criteria perspective. And we were hopefully going to have a discussion about that this past week, but the person that was supposed to collect the requirements didn't get it done in time, so we didn't have the discussion. But we will be having that shortly. So anyway, if you're interested, there's a GitHub issue. You can subscribe to it. You can subscribe to our mailing list. And hey, patches are welcome. You know, so. Anyway, as far as personal contacts, I already gave you my email address, but that's Richard's email address, RGB at Red Hat. He'd love to hear from you too. But I think Richard would probably tell you the same thing that I'm going to tell you, in that send it to the mailing list. Because if it's something you're interested in, odds are somebody else in this room is interested in it too. And it's better if we can get everybody talking together as opposed to having a lot of one-on-one conversations. So all right, so I think we've got 10 minutes left. I can go back over the conclusion slide if you'd like, but I'd rather answer any questions you guys may have, other than why isn't it done yet? I'm sorry, please.
You had two contradicting statements in your presentation. The first one was like that you want to allow to escape the audit space you want to have per host. And the second one is audit daemon the user namespace.
Okay, so the question, and correct me if I'm wrong, you said that we have two contradicting statements. I was actually kind of happy that it was only two. One was that we don't want anyone to be able to escape audit logging. And the other one was that you can only have one audit daemon per user namespace. You can have one audit, okay. So let me try and answer that if I think where you're getting at. Right now, you can only have one audit daemon. So we know that that's going to be a problem later. So right now we can only have one audit daemon, so you can't really escape auditing right now. Maybe I'm doing a poor job at explaining this, but it's a good thing. I mean, eventually we would like to be able to support running one audit daemon per user namespace. But right now we don't support that. And why? All sorts of things break. Basically, one of the issues is how do you start resolving the UIDs and the GIDs and the FSGID and the FSUID, and there's about 7 or 8 different user identifiers. What's that?
You can connect them over the PROCFS UID mapping tables.
Yes, but which one do we record? Yeah, see, oh, I'm sorry. Repeat the question. Now I have to remember all the questions. So I think basically the question was, why can't you have multiple audit daemons right now running in different user namespaces? Was that?
No, my question is like, when you say that you want to make sure that audit gets everything, and user namespaces by design can be created by unprivileged processes, by design you can escape the...
Okay, so just a minute, I'll repeat it in just a minute. I'm just trying to make sure I understand it. So you're basically wondering, in the future, when we can have multiple audit daemons running, how would we handle that? Is that?
No, I
Okay, so you're never going to be able to escape logging. All right, so the concern for the recording is being able to escape audit logging, right? Okay, so, and especially with user namespaces, because an unprivileged user can create a new user namespace. You're never going to be able to escape audit logging because the audit daemon running in the initial namespace will always be running, and it will always have visibility of everything that happens on the system because there is no audit namespace. This is one of the reasons we don't want an audit namespace. So that even if you create a second user namespace and you do run an audit D in that second user namespace, the kernel still has visibility into that second user namespace, and you can still configure the kernel to report on events that happen in that user namespace to the audit D running in the initial user namespace.
That means that you have user namespaces you have to, because you have a tree then of roots you have to use.
Keep in mind, and so to repeat the question, you're concerned about the actual UID values and whatnot from there?
No, I'm concerned about which filters are active. Because, for example,
Okay, so you're concerned. I'm going to answer this one question, and somebody else had one more. So I'm more than happy to talk to you after. I just want to make sure we get other things answered. So the question was, how do we handle the different filtering? So the filtering in the user namespace versus the filtering in the initial. So, and that's what we talked about. So we're going to have different rule sets. You know, you can have different rule sets for each user namespace. So the audit D running in the initial user namespace can be configured to watch everything if you want it, or you can turn that off. And a user running an audit daemon in their own created user namespace can have their own rule set. So basically, you can adjust auditing for the user namespace that you create, but you cannot escape the filtering and the logging that happens in the initial namespace. So, but I'm more than happy to talk about it later if you want. Last one.
Does it mean that the user namespace audit D will be able to suck audit events out of the host and expose that?
Okay, so the last question, the obvious question for security people is the audit daemon running in the user namespace, will that have visibility to audit events that happen outside of its own user namespace? No, we don't want to do that for the obvious reason.
You're talking about only the user namespace. What about network namespaces and stuff like that? They are not. How do you deal with that?
The way we deal with it today.
But today you can log anything that happens in all network namespaces.
Right.
But tomorrow you have a user namespace for different audit D. Will you be able to log stuff from it?
Remember when I said these are the problems we know about today? We're going to have, so his question was about the other namespaces, and my response is simply put, we know there's some hurdles we have to overcome right now, and I fully expect, like I said, as we get halfway down, there's going to be other concerns as well. This was a talk about presenting some of the problems and some of the solutions. This isn't a talk about saying, hey, here's our design, it's perfect. We don't have that yet, which is half the reason why we can't give it to you yet today. So if we had all the answers, we'd have it working. So anyway, if you're interested, if you want to help answer those questions, there's the audit tracker. There's the mailing list. So, all right. Thanks, everybody. I appreciate it. Hey, no, good, thanks.
Can I ask you, well, it's essentially a really stupid question at the end of the talk, but essentially I have a customer, I'm a consultant for Red Hat, I have a customer and they want to audit everything that happens in every container on the system, and essentially that sounds like no.
Well, no, we can. Actually,
Maybe
the
in
funny,
the future, but
the
not
funny part is the fact that we don't. The fact that we. Oh, thank you. Good thing I didn't start swearing.